So again, we're going over Chapter 7 on how to handle exceptions and validate data. What does that mean? You've already done some of this. If I ask you your height, and you say 107 inches, I wouldn't believe you, all right, because that would make you almost 10 feet tall. So what I might do is I might make limits. I might say that really, even when you're born, even if you're real little, you're going to be at least 12 inches. And probably the biggest person ever was 96 inches, which is 8 feet. So if I'm validating data, I can either say, hey, if your height is between 12 and 96, it's valid. Or I can say, if your height is either less than 12 or your height's greater than 96, it's invalid. In both cases, I'm validating data. And that's the rest of what this chapter is about. All right? So, it says, before you learn to handle exceptions, it's helpful to know more about how they work. Well, how they work is this. Going back to this program right here, if I have some kind of an error in this program, let's get rid of all this out stuff and everything. I just want it to work. Okay, so I'm going to get rid of this, and I'm going to get rid of that, and there. Well, now what? Corresponds to given parameter. Oh, here we go. There. All right. So I've got this. All right. Let's assume for a second that this calls another routine. All right. And I'm going to give it a stupid name, but I'm going to say static int another routine. In fact, I'm going to call another routine 1. And I'm just going to put in here return 0. I know this is a dumb routine, but I'm trying to show you something here. All right, and this will be another routine 2. Okay, so I'm going to say right here another routine 2, and this one will call first another routine 1. All right, so what do we have now? This routine, our main's going to call add2. Add2 is going to call another routine 1, which really doesn't do anything. All right, but first, before it does something, it's going to call this routine. So you've got a routine that calls a routine that calls a routine that calls a routine. Does that make sense? If I get an error in this routine, let's just assume there's an error. There's a lot more code in here I put in later, and there's an error. The system says, okay, there's an error here. It looks to see if there's any place in this routine where I'm accounting for that error. And if it doesn't find it, guess what it does? It jumps up to the routine that called that one. And it says, does that handle the error? If it doesn't find it, it goes up to the one that called that one. And it says, did that handle the error? If it doesn't, it goes up to here and it says, did that handle the error? So it went all the way back up. It does what's called bubble up. All right? If it goes up to the top and it doesn't find it, it blows up. That's how exceptions are basically handled. So it looks right where you are for an exception handler. If it finds it, it handles the exception right there. If it doesn't find it, it goes to whatever called the routine that's in error, and it says, do you have one that handles it? If it does, it handles it there. It just keeps going up what's called the call stack, which is a listing of everything. So the call stack for this function would look like this. Another routine 2, another routine 1, add to main. It does them in reverse chronological order. So it's got the newest one first. All right? And that's kind of, I mean, I'm not saying that, this is what you end up getting. Remember when we saw this? This is called the exception assistant. It tells you the name of the exception. It's a format exception. And it's bad enough, and it's not being handled, that the program stops. Okay? So in the worst case, the program will literally stop running, crash, whatever you want to call it, if you don't handle it. And that's what they're talking about here. Now, when you look at this, it says the exception hierarchy for 5 common exceptions. Who cares? Well, let's just look at what these are. A format exception. Look on the screen here, format exception. All right. Well, if I say something is an int and I give it a value that's got a decimal point in it, that's a format exception. If I say something is an int and I put a non-numeric value in it, that's an arithmetic exception. All right. If I say something can only hold a value up to 10 and I put 37 in there, that can be an overflow exception. Do I have to tell you what this one is? That's attempting to divide by 0. All right. So there are different ways that you can handle these exceptions. The good news, look on the screen. Have you been using these? You've used convert to int 32, convert to double. We just looked at the try parse. So that's why I said I'm not planning on spending a lot of time on this chapter because we've covered the stuff that's in here. And anyway, when you learn the most in here, it's not from me lecturing, it's from you trying stuff, because some of the stuff that you try is going to work, and guess what? Some of it's not going to work. That's just human nature. Like I said, I told you about my program that I'm working on right now in Android, that it works 2/3 of the time. You know, years ago, I'll always remember this. I had a student. He was really a belligerent guy. It's the only time in my life that I ever had 2 students get into a fight in class. He went into the lab, and there was nobody in there. There was a woman sitting there. She was a very big woman. She's an American Indian, and that's where he sat. And I heard it because I happened to be sitting up at the front of the room, and he goes, "Get out of my effing chair." Nobody else in the room with 25 seats in it. She's like, "Excuse me?" He says it again. So he starts to push her out of the chair. She gets up and decks him. All right. So he went, of course, complained about it, and they called me in, and they said, "Well, what do you think?" And I asked them to leave, and I talked to my boss. I said, "He deserved it." I said, if nothing, I was kind of proud of her for standing up for herself. All right. The point is, this guy, around that time, he's in a class with me in the C programming language. He comes in on a Monday, I'm not making this up, and he says, "Mr. Scott, you ruined my whole weekend." Yeah, I'm sure I did. But I said, "How did I ruin your weekend?" He said, "I spent the whole effing weekend," which I told him, no swearing, but he said, "I spent the whole effing weekend working on this program." All right? And I couldn't get it to work. But the good news is it works 90% of the time. And he could show me where it blew up. All right, he says, "But I think I should get full credit for it." I said, "So what you're kind of telling me is it's like if you were making a product that worked 90% of the time, that I should still pay full price for it." And he said, "Yeah." I said, "Why don't you go out there and why don't you market that and have it be your slogan? It works 90% of the time." And he goes, "Nobody would ever buy that." I said, "You just asked me to." And he thought I was being funny. I wasn't. It wasn't a play on words. It wasn't anything. But it's just, that's what he was asking me to do. The point is, your program, if you're going to put it out there where people are going to use it, whether they're paying for it, you directly, or whatever, it better work and handle every kind of possible exception. Because stuff's going to happen. You know, I lift up this C# book, and I'm reading it, and all of a sudden I drop it on the screen. And I've got some kind of a program on there. Oh my gosh, my screen is doing weird stuff now in this program. Nobody accounted for that. All right? All right, how to display a dialog box. Well, the good news is, true or false, you know how to do this already. You know how to create one of these message boxes? You know every component of the message box. You know the title, you know the text, you know the buttons, and even though they don't show it here, you know the icon. That's why I don't think we really have to spend any more time on this. Now, in Chapter 10, it says you'll learn how to use the message box to display even things that are more complex. Well, then we'll hold off till Chapter 10. All right. when you write code, if you use regular exception handling like this, you end up typically writing something that looks like this. You type in here, try, got a curly brace. This is code. I don't care what it is. And then down here, you've got one or more of these statements that say catch with something inside, and you've got code in there. Now this, one or more. So imagine I've got code in here. I ask you to put in your height. And I say you must put in a height that is between 12 and 96. Well, you've already seen this. We've done it with a while loop. All right? But suppose I don't use a while loop, and you put something in there that's wrong. Okay? So the program blows up. It throws one of these numeric format or arithmetic exception. I can catch that exception in here and do whatever I want to do with it. So when you are running structured exception handling, in this what's called a try block, you put in code that can conceivably fail. And in the catch block, you can have as many of these because there can be a lot of reasons that it fails. You can tell it what you want it to do. One thing you cannot do is you cannot say go to and then go back up there. I fixed it, now go back up there. You can't do that. You can carry on. So for instance, what if I did that and I said, okay, if it's a numeric format exception, basically just reset it to a default value. So the default height is 72 inches and just go on. That's okay. All right. Now, we're going to talk about this, but the way that you learn first to handle stuff that's out of whack by using a while loop, that's a better way than this way. All right, because treating exception handling this way usually really slows down a program. And I mean really can slow down a program. The only other way to treat exceptions is to do nothing and say, you know what, you're all smart people. None of you will ever put in bad values. Well, what happens if we do? The program will blow up. But I trust you. Yeah, right. You're going to write software like that, right? That just assumes whoever runs it, no matter who they are, the age, the whatever, they know what they're doing. Some people are always going to try to push the envelope. They're going to try to make you see, hey, I wonder what happened if I did this. Whatever this happens to be, it doesn't matter. All right, that's just human nature. I used to work with a guy who used to always say, I like to just see how far I can take management. And I put my foot right on the line where they're almost about to fire me. Then I put part of my foot over the line just to see what they'll do. And that's how he was. He just didn't give a damn. But he'd been there for 20 years. He was vested in the place. They couldn't really get rid of him. They tried firing him. All right. They fired him because they said he couldn't do his job. He was a teacher. But the stuff they said he couldn't do, he'd been teaching it for 5 years. So they said that they had a guy who didn't know how to do it, but they were letting him do it. So he sued and won. And they had to pay him like over $100,000. And he won. And then right before the next semester started, he quit the day before to try to screw the school, so to speak. I thought the whole thing was hilarious myself. I really did. All right. So this is what I just showed you. So notice in here, this is a try. You try to do all this stuff. This is a catch. Now, we're not even catching errors. If one of these fails, it's going to come in here and do this. It doesn't matter which one. If any of the lines that are in here fail, you'll do this, and then you'll go on. Does that make sense? All right. Sometimes, if an error is bad enough, you want the program to die. For instance, let's say that you're working with a database, and the first thing you do is you try to get the database. Guess what? There is no database. That's probably going to make it real hard to do your program. All right? That kind of thing. Or you ask for a file that's out there on a flash drive or whatever, and it's not there. All right? Somebody misnamed it or didn't put it out there. So notice in here, they put XX. Well, look on the screen. That's XX is going to fail, correct? So what's going to happen? It's going to come down here and do this. There's the message box. And what does it have in it? Come on, get out of there. It has, please enter a valid number. There it is. All right, entry error. There that is. If you don't put any buttons in, you only get an OK by default. And they didn't want an icon. I would have put an error icon there because it was an error. They didn't. It's okay. So again, you can use a try-catch to code an exception handler. How to use the properties and methods of an exception. What they're saying here is when an exception is thrown, there's information that the system grabs, and you can print it out if you want. You don't have to. The more you print out for somebody, look at this. Do I really care about any of that stuff that's in that big glob? No. I care about the thing on the top, though. Input string was not in a correct format. I care about that. I don't care about this. But we're printing out two things. The message is this line right there. The stack trace, those are all the routines that were called to get there. So I can look in here and say, well, look, there was a routine there, and a routine there, a routine there, a routine there, etc. Typically, when you go through this enough and you print out the stack trace, one of the programs that's in there is yours. It's a routine that you wrote, and maybe 10 of them are system routines. Guess which one is wrong? It's yours. All right, you say, well, no, mine's right there as are wrong. Yeah, right. Yeah, Microsoft's routines are wrong, and yours are correct. If you want to feel that way, go ahead. All right? You probably never end up actually, fixing your problem then, but if you want to use the properties and methods of the catch block, you have to supply a name. See that? See the difference? Now there's a name. All right? All right. The stack trace I already mentioned to you. If you're coding a try-catch within an event handler, you can't use E for the name of the exception. So see how they used EX? Don't use E because it already has a special meaning to the system. That's all. You can catch against specific types of exceptions. Here are, so notice here, there's a bunch of catches. See that? Format, overflow, etc. When you go to grab exceptions like this, you can look online to find this stuff. You can go out to msdn.microsoft.com and you can find out stuff about this. They actually have a hierarchy, and they go from the most specific exceptions to the least specific exceptions. Did you hear me? Exception, that's the most general exception there is. That just means the system found something it didn't like. What does that mean? It means the system found something it didn't like. So if you look up there, a format exception is more specific than an overflow exception, which is more specific than an exception. If you reverse the order, this will catch everything. Once it finds an exception that it matches, it skips everything else. It's like an if with a bunch of else ifs. That's pretty much what's happening here. And this would be a final else type of an idea. You can also, at the end of your try-catch, you can put in what's called a finally block. That's used for housekeeping. What does that mean? If I open up a connection to the database and there was a problem in my database and it failed, I'd want to close that connection. If I opened up a file and there was a problem in the file, I'd want to close the file. Now, if you forget to close the file or the database, typically it's going to be closed for you anyway, but this says close it immediately, not when you get around to it. All right? So it's considered good practice to do that. You can also throw your own exception. So imagine, let's pretend for a second that I had you do a program that was like this. We may have done one like this. I don't even remember anymore. But let's pretend we do a program that looks like this. Miles, gallons, MPG, and it'll calculate our clear and our exit. And we got this and this and this. This would be read only, okay? So I come through here and I type in 400 for gallons, I type in 20, and I hit MPG and it says 20. You all with me? Okay, makes sense? Now I come in here and I write hello. I think you all agree that doesn't make a lot of sense. I could write my own exception. All right, I could write my own exception that said you must enter a numeric value in here. So they come in and they enter a numeric value. And they put in, I don't know, 5 fives. But the maximum value you can put in there is 1,000. Would you agree we put in a value that's out of range? There is no system exception that says that's out of range. You can write your own if you want to. And then throw that exception. You can throw your own exception. You can throw one of those exceptions we just looked at, like overflow exception, arithmetic exception, number format exception. You can throw an exception. All right? If the system throws the exception, notice the difference. You throw an exception. No S on the end. The system throws, with an S on the end, an exception. All right? Sounds simple, and it is. All right? But the thing is, you have to put the word throw in there. So notice here, what we're saying is, hey, if you put in a negative monthly investment, we're going to throw an exception. And it's just going to put a message on the screen that it says, must be greater than 0. All right? We could have thrown that, and instead we could have put that into a message box. All right? You got total control over what you do and how you do it. It is literally, it's up to you. All right? So it says when to throw an exception. When a method encounters a situation where it's not able to complete its task. All right? It doesn't understand what it is. Based on what you tell it to do, you're giving it information that it can't do that. All right? Either you're not giving it information or you're giving it wrong information or whatever. When you want to generate an exception, you can test what you've got in there to make it happen. When you want to catch an exception, perform processing, and then throw it again. All right? You'll have to see examples of that to make sense. All right, so finally they end the chapter by going through this future value program that they've been working with, but now notice everything is in a try-catch block. So try doing all this stuff. First thing they catch is a format exception. If they find it, they do this. If it's not a format exception, they check to see if it's an overflow exception. If it is, they do this. If it's not a format exception and it's not an overflow exception, typically most programmers put just exception at the end. Something went wrong, but we don't know what it is. All right, so notice all we're writing here is just a generic error message, right? Here and here. But here, we don't know what the problem was because it's too general. So we tell the system to write the message for us to let us know what went wrong. All right. Validating data then. This is, I don't know how much is in this chapter. Let's see. We're on 202, so we got about 10 pages. Hopefully, we'll try to shoot it so we can get done at 10. All right, take a break, and at 10, when you come back, I'll give you your homework. All right, the labs that you're supposed to do for these 2 chapters, and then the rest of the period will be lab. Again, tomorrow will be lab for the entire period. All right? So, it says whenever a user enters data, that data normally needs to be checked to make sure it's valid. Again, that's the process of data validation. When it's invalid, what do? It depends on what you want it to do. Remember how we've used while loops to kind of keep you in a box, so to speak, until you put in what we want you to put in? That's one way of validating data. All right? So, how to validate a single entry. When a user enters text into a text box, we may want to perform several types of data validation. It says, in particular, it's common to perform the 3 types shown in figure 7.8. All right? This just says, is there anything in there? All right? Isn't that what I'm checking for? If it's empty, do this. This is going to check to see whether or not it's valid. Now, this is similar to what I showed you in the last chapter, but notice it's that try-parse thing. All right? And this checks to see whether or not it's within range. Quite often, if the more complex the application is you're creating, the better the chances you're going to have to check for all 3 of these. Right? You're just going to have to. however you do it, whether it's with ifs, with whiles, with whatever. If you look on the screen, it is possible to combine all of those into one if or into one while. You can do that. Sometimes that might be very well what you want to do. Other times it may not be. So the author says here, when the user enters data, normally it needs to be checked. That's data validation. When it's invalid, the program needs to display an error message, give them another chance, or maybe even kick them out. All right, have you ever done this? I don't know how it is on your own machines, but you know, when at the school I used to work at, the students were given machines to use. You got 3 chances to log in with your login and password. If by the 3rd time you didn't do it, it locked you out for a half an hour. That was how they handled it. So if you did it the first time and it was invalid, they said that you'd get a generic message that would say username or password invalid. They'd ask you to do it again. You did it wrong again. They'd come back with that same message. You did it wrong again. Boom. Now you're dead in the water, so to speak. All right. So again, 3 common types. Make sure that a required entry has something in it. If it's numeric, make sure there's a number in it, and make sure it's within range. All right. Just exactly what we looked at. It says here how to use generic methods to do data entry. All right. You can write your own generic method to do whatever it is you want it to do. Some programming languages, all right, some programming languages have a method that's called isNumeric. So you can check whether or not what you typed in was numeric. Now look on the screen here, because what I'm going to do is I'm going to come in and I'm going to say C#, oops, try it here, C# isNumeric method. All right, isNumeric function. It says it returns true if the data type of the expression is Boolean, byte, decimal, etc. All right, well, let's look in here. All right, and you're looking at it like, I don't know what the hell that is. You have to write your own method. You can call it isNumeric. And then you can check to make sure it's a number. All right, that's what they're saying. Some languages have a built-in isNumeric function. Some don't. All right. Oops. And here's the one that checks for a valid numeric format. Notice with all these, what is it returning? Bool, true or false? True. What you tried to do is valid. False. What you tried to do is invalid. How to validate multiple entries? Well, look, it gets a lot uglier. Okay. Here we've got one routine that's validating monthly investment and interest rate, etc. Typically, you're not going to combine all these together into one big invalidate or validate type of thing. You'll have separate ones for each. All right? Now, imagine that I asked you for, let's say, again, 5 pieces of information. First name, last name, address, city, state. Let's put zip on there, 6 pieces. All right? I could put all those in there as strings. And let's just say that that was all I wanted to check. Is there a value there? And is it compatible with the string? I could write one generic method and have it handle all of them. But if I say that the zip code has got to be 5 numbers or 5 numbers with a dash and 4 numbers, now I got to write a separate method for that. Or put it in there like they did here. This is ugly. I think you're much better off writing separate methods for each thing you're trying to validate. All right. So as it says, both of them will work. So finally, they go back again to this future value application, and they redo it with data validation. So notice, there was nothing in the interest rate. Boom, they come back with this saying it's a required field. All right. They wanted this to be a decimal. Now that's not wrong, but they wanted 100.00. You didn't put it in like that, so they refused to accept it. Here the monthly investment must be between $1 and $1,000. Well, we left it blank. So here's that generic error. Now that's what's tough about the exception. Usually this is what you get for an error. An unknown error has occurred. Well, that helps you a lot. But sometimes by looking through this and going through that stack trace, look on the screen here. See this? It's telling you in your code in line 40 is where it found the problem. All right, so that can help as far as digging through and finding out what's what. All right, the rest of it is just showing the code that's in there. All right. So again, I want to say this one more time. We're taking a break now. I've got to clean up your labs, and I'll give those out to you before we leave today. All right. They like the test, and here's the Chapter 7 written test, which I just have to staple. Do the same thing. Put your name up there, and then do Friday 2/7. If for some reason I'm not here next Friday, they're still due then. You leave them up on the top here, and I'll tell Mr. Corrigan to pick them up for me. All right? If I have to take those guys in, I have to have them there by 8. All right? And it's farther than the St. Louis campus. All right? It's down in St. Louis. I've been there before. And they have to be there by 8 to get registered and everything. The test starts at 9. It goes till 10:30. Then they have to grade the test, and that takes an hour. And then they announce who's won and what places. So last time this happened, I didn't get out of there till like 1:30. So your whole class, I wouldn't be here. Now, when I did that, I was part of the team, so to speak. This year, I've got students, but I'm not part of the team. The people from St. Louis are doing it. So again, my hope is, I'll let you know Monday, because I'll ask these guys today. All right. Well, one of them wasn't there yesterday, so I couldn't ask all of them. I'm just going to say, you guys all have rides, right? And I'm praying to God they all say, yeah, good. All right. So next week, because I want people to catch up, if you're behind, Monday will be lab for the entire day as well. All right. Tomorrow I will quickly go over the multiplication table problem. All right. And then after that, we'll go in and the rest will be lab. Monday will be lab. All right. On Monday, I'll let you know what we're doing for the rest of the week. If we have a test next week, if they're not going to come, it'd be Thursday or Friday. All right. Probably would be Thursday anyway, but I'm not sure. So we'll see. All right. Questions? All right. Because that's all I had then.